Okay, so this is a photoresistor, and this is what we're using in the next part of our hack. So what it does is, due to something called the photovoltaic effect, which Einstein won his Nobel Prize for, when light hits it, it'll change its resistance. So it's like a regular resistor, but the resistance changes based on like how much light is hitting it. So as you can see from the circuit up here, this is our circuit right here. As you can see, we have a 5-volt source from the Arduino, and we have our light-dependent resistor here in series with our 120 ohm resistor that we used before. But the difference now is that where they connect, we also connect it to pin A0 on the Arduino. So A0 means analog input 0. This is because if you use any of the digital pins that you have on the other side of your Arduino that we were using before for output, if you try to use those for input, you can use them for analog input and digital input, but this is usually what's required for analog input. In this case, we're measuring the voltage that is coming from this point. So the reason that we can measure the voltage from here is because the light-dependent resistor, it changes its resistance depending on what kind of light is hitting it. So because it changes its resistance, the amount of voltage that gets dropped across it varies depending on the resistance. So the reason that happens is more theoretical. We won't go into it now. If you're an E40, you should know this. But here, if we connect something here to analog input, then we can basically measure the voltage level here, compare it to our ground over here for the Arduino, and be able to tell what kind of voltage difference we have here. And that'll depend on what kind of light is hitting the photoresistor. So let's actually build the circuit now. So we're going to basically hook it up similarly to how we hooked up the LED. Basically, it's just a resistor and the photoresistor in series like this. The photoresistor doesn't have any polarity. It's just like a regular resistor, no polarity, unlike the LED. So let's just wrap the resistor around here again. Okay, so we'll stick one end of the photoresistor into 5-volt right here. You can see. And then, so this middle pin, remember how we said the line comes out of here? We want to put it into analog 0. So we'll put this here, we'll put this back into 5 volts. So this basically just means that you see this is where the resistor and the photoresistor connect. And then it's also connected to A0, so then we'll be able to get a voltage reading out of here. And then this needs to go in ground. What's the closest ground that we can plug into?
This is probably right behind.
I'll have to do a little bit of acrobatics here. Okay, so now we have one end of the photoresistor plugged into 5 volts. The point where the photoresistor and the resistor connect, that's into analog 0, and then the other end of the resistor is in ground. So the reason we can read the voltage from here is because, remember, voltage is a relative quantity, right? So if we're able to read the voltage level right here and just compare it to our ground on the Arduino, because we have this plugged into ground, we can tell what the potential difference is, what that whole voltage is, between ground and here. And that'll vary based on, how much light is hitting the resistor, as we explained before. So let's fire up our Arduino, and the code that you should have written will establish a serial connection, and then that will take in the reading from A0 and just print it out to your computer. So go to your program, load it up. Okay, see it's writing here. Okay, it's uploaded. And now if I open up the serial monitor, okay, Michelle, you should come see this. Can you? Can you zoom in on here? On the line square. Is that good?
What do you want to see?
I just want to see the numbers scrolling by.
So we need one video of the numbers, and then another separate video of us like putting our hand over it.
So as you can see, the numbers are changing based on the ambient light. That's just small fluctuations. But if we put our hand over it, that'll change.
Is it changing?
And take it off, and it's changing again. So there we have it. It's a simple light sensor. You just use 2 components, plug it into the Arduino. You can sense when your hand is going over it and when it's going off. So yeah, that's basically how you use a photocell as a sensor. And in the next workshop, we're going to be covering other sensors that you can use.